Hi, everyone. My name is Simona Milanovic, and I'm an Android developer relations engineer working at Google. So, most of us are familiar with Jetpack Compose and its benefits. Simplifies and accelerates UI and Android development, less code, powerful tools, and intuitive Kotlin, right? So we won't talk much about this. If you're able to start anew and create a Compose-only app, you're on the right track. But then this talk might not be for you. While Compose only is a dream experience, the reality is that existing apps will be mixed views and Compose for a long time. And while our current guidance focuses on building new screens with Compose, the most common migration strategy we've seen across apps is all new features and screens written in Compose, while old code remains in views. Depending on the capacities, developers do refactor old code as well, but it's not a must. And this is important to know when deciding whether to start migrating to Compose or not. You can reap the benefits of Compose in a mixed app. Views and Compose can coexist and they can work together, and the sooner you introduce Compose, the easier your maintenance will be in the long run. The future of UI is Compose only, but if you're migrating an existing app, the present will require interop with views. With that in mind, this talk follows migrating a view sample without going all the way to 100% Compose, keeping it in an interop state. However, migration to Compose requires a holistic approach, looking at it as a comprehensive process with a start and an end, and a path to follow. So this talk aims to capture that specific journey and provide you with the steps and the toolkit to migrate successfully. So our agenda for today consists of presenting the concrete goals of this migration and what hypotheses we actually want to test with this migration, along with several phased-out tasks, starting from the smallest, going to the biggest, some non-technical tips to follow along the way, and a summary of this entire journey. So let's start with why we're actually doing this. To unblock any feature work with Compose and avoid maintaining duplicate UI in both views and Compose, we need to be able to migrate our common UI components first, shared UI, or in larger scale, design systems, with minimal changes to the non-UI layers, which would then unblock parallel migrations of entire screens or features via this so-called bottom-up strategy. Now, to reduce the migration workload and use Compose only for new code, we can rely on interop APIs to validate that this refactoring of old code is actually not a must, and that this incremental migration to Compose works well. So you can, if you want to, of course, and there's very clear benefits of why you can go and should go 100% Compose, but it's not a necessity, and you can rely on interop. Thirdly, this migration aims to keep using the same Jetpack navigation or your custom navigation framework, even for screens that are the entire screens are in Compose, or your contents of the screen are in Compose, and making this incremental migration to Compose less work. Using Navigation Compose isn't a requisite for using Jetpack navigation. This migration also aims to introduce support for large screens almost for free and uncover some tips and guidance on adopting the right mindset about this from the start. If you've used one component in views, you might not need the same component in Compose. Take advantage of this migration to actually rethink the implementation of some of your screens or elements, change them, simplify them if needed, by, for example, replacing a view constraint layout with a few Compose rows or columns. So how does a holistic migration process look like? Let's break this down into smaller tasks. We'll first go through some prep work, setting up the dependencies and theming. Then we'll move on to the migration of the smallest elements first, and then to some of the more complex ones, followed by the migration of low-risk screens, and then moving again to some more complex ones. So let's start with some prep work. A beginning is the time for taking the most delicate care that the balances are correct, wisely said Frank Herbert, meaning do your prep work well. It's very important to do this step well before actually starting. Migrating from views to Compose can be a mammoth task. It takes time, and you should prioritize safety over speed. So firstly, make sure that your app is in a good position to start the Compose migration. And this means checking if, for example, there are any structural blockers, minimum SDKs, or not using Kotlin, something like that. Any frameworks like testing, navigation that are too tightly coupled with your Vue APIs. Are you applying or can apply UDF as it is? Are you following the best architecture practices? What is your team's knowledge of basic Compose? And ultimately, do you have the time and the resources at this stage for the learning curve of Compose? Secondly, make sure you go through all the documentation and the materials. Well, not all, but migration-related, at least. And I say this knowing how much people actually love to read documentation, but please do check it out, as we have a comprehensive set of docs to help you kickstart this process. Then analyze and understand your app thoroughly. Let's introduce our sample protagonist for this talk. In our case, the starting point is Reply. This is a sample that is Vue-based. It's a simple email app with basic functionality of displaying emails, filtering, organizing, and navigating between screens. It consists of search, home, email, and compose. Compose meaning composing an email, in this case, screens. It's not confusing at all. And as a sample, it's aimed at showcasing a singular concept, material components in this case, and it oversimplifies the rest by design. It uses Material 2. So rather than migrating to Compose and Material 3 at the same time, we chose to split this into 2 tasks to promote an incremental and a safe migration process. However, we do encourage you to couple Material 3 with Compose to unlock its full potential. You might have noticed here that we actually migrate existing screens rather than writing new ones in Compose like we previously said. But this is only because Reply is kind of an elderly sample with no new features planned anytime soon. So we chose to refactor existing screens instead, as this approach still tests the very same hypothesis of Compose interop capabilities. So do keep that in mind. And finally, the last one is dividing and conquering the actual workload. So like we said, you want your initial migration steps to actually define them in a way that unblocks the rest of your team ASAP, right? By migrating usually the common UI or the design system first, so that they can then start developing new features and screens in Compose. And this is something that we call the bottom-up strategy. Now that we've done all this and came up with a plan, it's time to start coding. Every step in this talk will have a most valuable player and a pro tip as a way of building a broad migration toolkit for you. So in this step, our MVP is definitely screenshot testing. It's a crucial thing to facilitate, as migration from Vue to Compose can develop some difficult-to-catch UI regressions. To learn more about this, about Compose and screenshot testing together, you can take a look at our Now on Android implementation and also check out the easy screenshot testing with Compose talk later today. Another great opportunity for Compose migration is when there's an incoming redesign of a feature, screen, or a big chunk of components. You will have to do some rewriting anyway, so why not do it with Compose? Now that the prep work is done, first code change would be adding Compose dependencies, and theming would often be the second code change, right? But since setting this up is kind of a basic thing, we're gonna fast forward this and jump into the migration of the smallest shared UI first. If you're curious about this and any other steps that we're going to portal our way out of, you can check out this talk in the form of a blog series that has a lot more details that you can follow. So why do we start with the smallest shared components? Well, the following 4 steps that you can actually see follow our recommendation for something that we call a safe and incremental Compose migration. And this starts with the smallest shared UI first, and then we gradually scale to the more complex components. Thirdly, we start migrating or writing low-risk screens or low-complexity features, and then again scale to more complex ones, the ones that are high engagement. So for this specific step, what we're going to do is find the smallest shared UI in our reply sample first. So we look for the smallest reused XMLs and elements without a lot of binding variables, least data pulled from the network, the least dependencies required, like, for example, Glide. In our case, that will be the account item, then recipient chip, and finally, the search suggestion item. Next step is to understand how to design for large screens at this component level. So let's explain this a bit more. Once you've flagged the components in your app, try to think about them in different screen sizes. And for that, an important concept to understand this is the difference between app, screen, and component-level composables, and how each of these levels actually fits into the large screen support story. App-level composable is the single root composable that occupies all space that is given to your app and contains all of the other composables. Screen-level composable is contained within this app-level composable, and it occupies all the space that is given to your app. And generally, it represents an individual navigation destination. And finally, the individual composables or component level. All other composables, individual elements, reusable groups of content, or composables that are hosted within the screen-level composables. Now, for our case, this step was actually based on these individual composables. On this level, try to think about how, instead of being tied to some fixed screen-reliant values, how composables should occupy the real estate that they're being given. Composables should be able to fit any area that they're being given well. And this is where the bottom-up migration strategy works best. So you first build your smallest adjustable components first, and then gradually you think larger. Screen-level composables can then rearrange these smaller composables based on the available spot size, screen sizes, designs, or anything else that is relevant for this. Now, to set the right to large screens data mindset at this component level, you can actually refer to the following checklist, and it's going to have a bit more text, just a small warning. It covers points for building a large screen compatible component at this level. First one is always pass a modifier, which you probably know. Make it fully reusable by defining its parameters very precisely to a very granular level. Make it stateless by hoisting state. Take advantage of the slot APIs for added customization. Don't constrain them to physical values, hardware values, but to the real estate that they're being given. Rely on adaptive APIs for this specific purpose. Define the parameters for all screen sizes. So, for example, tablets might have more room to show something that a classical phone display won't have. So keep that in mind when defining these parameters. And finally, add previews and multi-previews for all screen sizes. Third step is to actually migrate some of the elements to Compose. So now that the migration of these three elements also belongs to something like a basic Compose knowledge, right? We're going to fast forward that as well and go to how we actually use these composables. Again, if you're curious about the detail stuff, do check out the blogs. Now that we have the search suggestion item in Compose, being a good Compose scout, for every new composable, we actually add a preview, but you kind of knew that already. However, since Reply has a light and a dark theme, we actually take advantage of multi-previews to preview the search suggestion item in both. In Compose 1.6, preview light-dark annotation was added to actually remove all of this manual creation above. So it does the work for you. Now we're actually ready to hook in the first composable, right? In our search fragment, we replace the old code and the binding with the new one, with the new composable. We do so by adding the compose view directly to the parent binding and replace the old suggestion binding. When using composables and views like this, it's especially important to understand the concept of setting the right view composition strategy. View composition strategy is needed when using Compose in views. It defines when the underlying composition is going to be disposed. And there's a few scenarios of usages here. So, for the first one, the composition is actually disposed when the compose view is detached from the window. And this might happen when you have a single compose view or mixed view and compose screens that are not in a fragment. Secondly, this one disposes of the composition when the compose view detaches from the screen, from the window, unless it's part of some sort of a pooling container. And this is when you have a compose view that is an item in a recycler view, for example. Thirdly, this one disposes the composition when the provided lifecycle is destroyed. And this might happen when you have a compose view in a fragments view. And finally, this one disposes the composition when the lifecycle owned by the owner is destroyed. And this might happen when you have a compose view in a view when the owner is not known yet at this stage. Now, for a lot more detail about all of these individually and how to use them, you can refer to this blog, and it might help you understand this a bit better. So now that we actually realize that we have a compose view in a fragment and we want to dispose when the life cycle owned by this owner is destroyed, we use this strategy specifically. Moving on to the compose recipient chip. This actually shows a very interesting compose interop capability. So the original element is a material chip, which is added to a chip group in a compose fragment. This chip group acts as a flow layout container for the chips, meaning it fits as many chips as possible in one row, and it can overflow to the next one if you want it to, right? So now that we have the chip as a composable, what we do is we add it to the compose fragment, and we just simply replace the old view chip with the new compose one, directly adding it to the view chip group. And that's all it takes. There's nothing else that you need to do. Even the more complex logic of expanding the chip, this was predefined previously, and this handles the view chip's expansion and collapsing behavior. This still works with the chip composable. And I find this to be pretty cool because it actually helps ease your migration workload by not having to rewrite the complex custom behaviors such as this one. You just keep it the same. And you change it when you want to, if you want to. Another proof of interop just works is the account item. Now, this was previously used as a recycler view item binding. Again, now that we have its composable replica, we just replace the old binding item in the view holder with the new composable, and it works again without any other changes. Just make sure that you're using the latest versions of recycler view and compose to ensure that they're well performing together. So as a reward for the last one, you get to do some fun removal of old view code lines, XMLs, styling and theming resources, custom binding adapters, etc. Now, the MVP for and pro tips for the specific steps are flow layouts. Now, remember, Compose isn't always a one-to-one mapping, like we said, right? Since the chip group is just a more opinionated flow layout, you could consider replacing it with an actual Compose flow layout, like a flow row or a flow column. And since Compose 1.4, we actually introduced flow layouts as well. When it comes to the pro tip, for if you have like a large parameter list in previews that you need to pass, you can use the preview parameter annotation for much better readability. So another one bites the dust. We're moving on to the next one. So this task actually deals with more complex components, but for the efficiency of this talk, we're actually going to merge it with the following step. So our candidates for complex components and low-risk screens in reply are a staggered grid of images attached to an email and a fairly simple search screen. Now, one of the biggest advantages in Compose, in my unbiased opinion, are lazy layouts and their simplicity compared to recycler views. Therefore, this step rightly aims to remove as much recycler view code as it can and replace it with Compose. So we start by replacing email fragments recycler view XML with a Compose view, keeping its positioning constraints as is. We then find the previous recycler view binding where it was used in the email fragment, and we add this. And that's all it takes, right? No view holders, no adapters, just a vast amount of code removed by migrating just one component. Lazy layouts also have some really cool APIs to support large screens at component level. Arrangements make the customization of lists and grid in Compose much easier and adjustable for all screen sizes. While, for example, the grid cells adaptive defines a dynamic and adaptive size of your grid by setting the minimum size of an item and letting the grid fit as many columns or rows as it can in the given space. Now, this is super useful when supporting large screens and creating a great adaptive user experience with almost minimum effort needed. Now, for the search screen. Since at this point, all of our fragments have a bit of Compose code in them, we're able to move on to the screen level migration. On this screen level, there are different tiers of large screen supports. Some require major design changes and layout changes, like, for example, implementing list detail layout or other canonical layouts, while some require just some basic support, which is not to be letterboxed. Early in your migration, try to target screens that require the least amount of layout changes and that are also low risk to migrate to Compose. Search screen was the perfect candidate for that, as it is low engagement and it's a low complexity feature. Since all individual pieces of the screen were already converted, migrating this screen specifically was very easy. Now that the entire UI of the search fragment consists of a search screen composable, we keep the fragment only as an outer wrapper to continue using the same existing navigation framework as it is, and the transitions that come with it. At the screen level, we actually start adding device multi-previews as well to ensure that our composables look great on all screen sizes, phones, foldables, tablets, etc. And this marks step 4 as done. Moving on to the last step, migration of more complex screens. This starts with a search of the best screens. A previous step was looking at low-risk, low-engagement screens, with minimal changes required for supporting large screens. But in every migration journey, there comes a time for those riskier and more complex screens. So fear not, there is a safe way of doing this as well. This is a great time to involve your designer and rethink some screens with this large screens mindset. The functionality in the UI of your classical layout doesn't need to change. And you'll be able to leverage the power of Compose to build reusable, adjustable components from the start. And then you combine them differently based on the screen sizes. Canonical layouts play a major role in providing the best user experience in this case, as they consider the common use cases of how apps adapt visually to more or less space. So analyze your app and flag some screens that could be a good fit for some of these. For example, the list detail, the feed canonical layout, or supporting pane layouts. In reply, the candidates for what we want to do are home and email fragments, as they fit the list detail layout perfectly. But how do you approach designing for large screens at the screen level? To set the right mindset for this specific level, you can use this cheat sheet for screen-level composables. So, firstly, you can start with low-risk screens that require least design changes and, again, scale to high-risk, more complex screens like we mentioned a few times. Secondly, make decisions that are based on the space that is allocated to your screens and not when it comes to fixed hardware values. When given a certain amount of space, think about how to best use it to display certain information to your users. Think about how, for example, canonical layouts can help you with that. Make sure you ensure consistency during configuration changes, like, for example, maintaining a logical navigation or scroll state the same when you make any certain sort of configuration changes or change orientation, etc. Secondly, use window size classes as an observable state to define these content types for your screen types. Then use this state to pass it to screen level composables only. Do not pass it to lower levels directly. And finally, do rely on adaptive tools. So, adaptive tools, when it comes to adaptive tools, this is kind of a set that you can, like a toolkit that you can use and rely on. You can use the Grids adaptive and span APIs, window insets, canonical layouts, flow layouts, previews and multi-previews for all screen sizes, resizable emulators, scrollable modifiers, fill max modifiers, weights, then followed by adaptive arrangements for lists and grids, and other adaptive utils, like, for example, the accompanist. Now that we've kind of covered this design process, the next step is to actually migrate these screens individually first. We start by migrating home and email screens. And writing composable replicas of these two fragments is actually pretty straightforward because all of the previous elements were already migrated. So we're actually going to fast forward that. So now that we have the individual screens in Compose, we need to pair them up in the home and email list detail. Whenever there's enough room to show the expanded layout, we want the home screen to actually serve as a host to display the email list and email detail in this canonical layout. Otherwise, we just want to show it in a compact mode, similarly as to what we had before, one screen at a time. To help make us make the right decision. We actually use the window size classes to define these screen types. Using window size, we convert the raw screen sizes into meaningful sizes and classes that are grouped then per buckets. So this information can, as mentioned, we always need to pass it just down to screen level composables. For lower level, we shouldn't use the current window metrics directly, but rather use the space that is actually given to the composable to render itself. So it kind of makes this decision a bit differently. Then, once we have this state, we actually pass it to the host of this list detail layout, which is, in our case, the home fragment, and its corresponding home screen UI. Within the home screen host, we then make a decision based on this content type, right? Show only the email list in home in compact single pane mode, or otherwise, show the email list and detail in the list detail canonical layout. Here we actually use a two-pane layout from Accompanist as a handy, quick shortcut to quickly set this up, to set up the list detail canonical layout and set other information like the strategy on how these two panes need to be laid out. However, it's really, really simple to write your own two-pane layout if you wish to do so. Now, to provide the best user experience, we actually want to be consistent during these configuration changes, as we mentioned. One way is to keep the same scroll position on our email list when switching between compact and expanded. For example, when we rotate a tablet device. Since home screen host actually decides which modes to display, we host a singular scroll state there, and we then share the state between the email list in single pane and email list in two pane. So everything so far was home screen and its fragment so far. So what about the email screen and its fragment? If the email list is in single pane and we tap on an email, we still need to handle navigating to the email fragment and showing it as a standalone, as we did before the migration. But in expanded mode, we merely need to update the email that's being shown without any actual navigation performed. So we have two different approaches. Sorry. Home and email UI, sorry, it started bugging out. Home and email UI is now entirely in Compose, but we keep their individual fragments as outer wrappers to maintain the navigation as is, and to maintain this flow of navigation for both use cases. Sorry. Now, to do this, our on-email click behavior in home screen is different depending on whether we want to perform an actual navigation action from home to email in a single pane, or if we just want to update the already visible email composable with the new data into pane. So we have two different actions that are being passed in the same place. And those two actions are going to define our navigation or almost navigation route. There's a lot more of this step in this of this task in this entire step, which we simply cannot cover in one single talk. So last reminder, take a look at the blog and take a look at the repo as well. It might be easier to follow this along there. Last but not least, our MVPs and pro tips for this section. Reply has a view bottom bar that surrounds the entire app and all of our nested composable screens, and this collapses on scroll. So now that our home UI is in Compose, how do we maintain this collapsible interop between use and composables? It's very simple. It almost looks like magic. All you need to do is use the remember nested scroll connection and pass it to your scrollable composable. And if you want to see how that looks like in code, do check out the repo that you can find on this link. It serves as the main repo for all of this talk. Finally, for the pro tip, display feature is something that we use a lot when we work with canonical layouts, and it serves as a description of the physical features of your device display. So for example, you have a folding feature that describes the fold or in your flexible display or a hinge between two physical panels. It works, you use it similarly to window size classes, and you just pass it as provided to pane. So with this, we conclude our final step, and as well as the migration journey. Now, since our line of work still requires some human touch, let's quickly cover some of the non-technical tips that might help you through this process. Migrate safely and incrementally the code that you feel comfortable or just slightly uncomfortable migrating. And do remember that your app does not have to be 100% composed to reap its benefits, and you can rely on interop. Not everyone needs to be a Compose expert to start writing Compose code. Like, you can learn on the go and while writing or reviewing someone else's code. The beauty of Compose is that you can achieve the similar or the same result in multiple different ways, all potentially equally correct. And there is an extensive set of materials to help you with this journey, but in the meantime, the best way of learning is simply by doing. And have fun. This is something that I often forget myself. You get caught up in deadlines and design requirements and growing piles of Jira tickets, and you forget that we're in Android development presumably because we actually love making apps. So having fun while doing so is kind of a mandatory thing, and Compose does help with this feeling quite extensively. And finally, yeah, have fun removing view code, because I know I did. And yeah, that's a wrap on our migration journey. I hope that you find this useful and that you were actually able to get some tips and a toolkit that will help you migrate to Compose more easily. Once you kind of get more comfortable with Compose, migrating screens and components does become faster and more rewarding, reducing the time it takes to write a feature, reducing the amount of code, and improving overall readability. To enable this, consider migrating your common UI and your design system first, but make an informed decision whether to keep both views and Compose, or whether to just move to a Compose unique design system. But it can be a daunting task for larger code bases, and we do acknowledge that. That's why refactoring old code is not a necessity, and you can rely on Compose interop for building new features and screens. Additionally, to ease this migration workload, you can keep using your original navigation framework and only think about moving to Navigation Compose once all of your screens are in Compose. But do remember that views to Compose doesn't always need a one-to-one mapping. And if you're redesigning certain features or screens, consider taking this opportunity to actually adopt Compose along the go. This also opens up possibilities for introducing large screen support along the way. Thank you.